This is the topic 2 video for chapter 6, solving systems of equations using substitution. So we have done solving systems of equations graphically, but sometimes we can find that if we're dealing with fractions and decimals, it's not always the most accurate way to solve a system. So we're going to algebraically solve a system using a method called substitution. This slide is an outline of the steps we are going to use. This is for your notes, but we are going to follow these steps on the next slide as well. Right, so we are being told to solve a system using substitution. What that means is we look for an equation that has an isolated variable on one side. So what that means is we look for the variable that's by itself on one side of the equal sign. So that second equation is set up already for us to substitute. What it's telling us is that 3 plus x is equal to y, therefore we can substitute it into that first equation for y. So we already have y is equal to 3 plus x. That's the solving for one variable. It was already done for us. So now we substitute. So we'll plug it into the first equation. We have x plus, and now we're substituting, instead of writing y, we are writing 3 plus x. And I like to use parentheses when I substitute in case there's multiplication. In this problem, there is no multiplication, but it's always good to get in that habit. And that's equal to 5. From here, that means we have x plus 3 plus x is equal to 5. Let's get our like terms together. 2x plus 3 is equal to 5. Solve that equation. Subtract 3 from both sides. And divide by 2. That gives us x is equal to 1. So that's important, but we are not finished. Now we look at that purple step. It says plug back in to find the other variable. So I'm going to plug it back in for my x value in this equation. That means I have y is equal to 3 plus x, which is 1. Therefore, y is equal to 4, and that is the second part. But I'm still not done because I always have to write my answer as an ordered pair. So x comma y, 1 comma 4, and that is my final answer. You can check your solution by plugging in 1 and 4 back into the original, so you can do that on your own, but I will not do that here. We're going to do 2 more examples on this page, so let's follow along. So in example 2, the first one on this page, we don't have a variable by itself already on one side of the equal sign, so what we need to do is change one of them. And because here I have an x with no coefficient, I want to solve for that x. So I am going to subtract 3y from both sides. That will cancel out, and I am left with x is equal to 7 minus 3y. Now I have my step 1 complete. I have a variable by itself on one side of the equation. So now I'm going to take what I just solved for, that's equal to x, and I'm going to plug it in for that x in the second equation. So again, remember to use parentheses 4 times the whole expression 7 minus 3y. Then I need to subtract 2y, and that is equal to 0. Distribute. And I need to get my like terms together. So I have a negative 12y and a negative 2y, make negative 14y, and I have a positive 28 is equal to 0. Subtract 28 from both sides, and I get negative 14y is equal to negative 28. Divide both by negative 14, and I get y is equal to positive 2. Again, I have one part of it done, but I'm still not finished. I need to take that y is equal to 2 and plug it in for the y in my isolated equation. So it tells me x is equal to 7 minus 3 times y, and in this case y is equal to 2. Negative 3 times 2 is negative 6, and 7 minus 6 is positive 1. Again, I am not finished until I write my answer as an ordered pair. My x value is 1, my y value is 2, and feel free to check those answers plugging it back into both equations. In my third example, I have something that is different than what we've seen. I have y equals, and y equals. When we have this, we just set each of these equal to each other. So what I mean by that is I can take 3x plus 4 and set it equal to negative 1/2 x minus 3 because they are both equal to y. I don't really want to deal with the fraction right now, so in order to get rid of a fraction, I can multiply the entire equation by 2, as long as I distribute to every single term. When I'm doing that, I get 6x plus 8 is equal to, the 2 and the 2 in the denominator cancel out, so I just have a negative x minus negative 3 times 2, x negative x minus 6. All right, let's get my letters to the left. Add x to both sides. And subtract 8 from both sides. 7x is equal to negative 14. Therefore, my x is going to be equal to negative 2. Again, I need to plug this back into one of the two equations. I'm going to use the first equation because I don't want to plug it in with the fraction. I think it's easier to plug it into the first one. So y is equal to 3 times negative 2 plus 4. So y is equal to negative 6 plus 4. Therefore, y is equal to negative 2. And last but not least, I need to write it as an ordered pair. My x is negative 2 and my y is also negative 2. And we could check those algebraically back in. All right, we're going to go way back to the first time we solve equations. And what does an answer look like that has no solution? When something has no solution, we get something like 0 equals 4, or negative 2, negative 2 is equal to 3. Those are false. So when we get those when we solve systems as well, and when that happens, we just write no solution if we get something false. What would an answer look like that is all real numbers? Well, it's when we're left with something like 4 is equal to 4, which is true. Or negative 1 is equal to negative 1. And that's where we say, instead of saying all real numbers, we say infinitely many when we talk about systems. Wow, that did not look very nice. Many. There we go. Go ahead and do the U-try, and then we will do the notes on the next slide. All right, we have 2 more examples left for the notes. So if we start with number 1, we notice we already have x equals by itself on one side. So I'm going to take what x equals and plug it into the bottom equation for x. 3 minus y plus y is equal to 7. So that negative y and that positive y cancel out. So I'm left with 3 is equal to 7, which is false. Therefore, I have no solution to this system of equations. So we have parallel lines. In the next one, we do not have a variable by itself on one side, so we're going to have to do that. The top one has y with no coefficient, so I'm going to subtract 2x from both sides. That changes my equation to y is equal to 4 minus 2x. I'm going to take that and plug it in for y, because it is equal to y. I have 4x plus 2 times y, which is 4 minus 2x, and that is equal to 8. Let's go ahead and distribute. 4x plus 8 minus 4x is equal to 8. So I see what's going on here. I have a 4x and a negative 4x. Those cancel out, and I'm left with 8 is equal to 8, which is true. That means I have infinitely many solutions. Do this U-try, and that will conclude your homework for tonight.